While loops. In this video, we will represent iterative processes using a while loop. Iteration. In the previous two units, we introduced the first two building blocks of an algorithm, sequential instructions and selective instructions. In this unit, we will introduce the third and final building block, iterative instructions. An iterative instruction, or loop instruction, is an instruction that executes 0 or more times for as long as a specific Boolean expression evaluates to true. Before a loop instruction gets executed, a Boolean expression gets evaluated. If that expression returns true, then and only then does the loop instruction get executed. This process repeats itself until the Boolean expression returns false. If the Boolean expression returns false the first time it's evaluated, then the loop instruction never gets executed. An infinite loop is when the Boolean expression always returns true, causing the loop instruction to execute an infinite number of times, or until the computer crashes. If a break instruction is executed inside of a loop, this will cause the program to exit the loop. And if a return instruction is executed inside of a loop, this will exit the loop and the invoked method. Writing while loops. The following is an example of a while loop. Okay. Now, all while loops begin with the keyword while. That is then followed by a Boolean expression. While loops always begin by evaluating the Boolean expression first. If the expression is true, then the loop body executes. This two-step process repeats itself until the Boolean expression returns false. So, once again, after evaluating the Boolean expression, if it is true, we then go to the loop body to execute it, which will execute for as long as the Boolean expression returns true. The following code demonstrates how to use a while loop to print values 1 through 5. Okay. So here's the code, and the first thing we're going to do is declare an int variable named x and initialize it to 1. Then we're going to enter our while loop. And in this while loop, the expression is while x is less than or equal to 5. So let's evaluate it. That's the first thing we do. So is x less than or equal to 5? Yes, it is, because it's equal to 1. So that's a true statement. So we go inside the loop body, where it tells us to print out the value of x, followed by a space. So we do that. We print out 1. Then the next line tells us to increment x, which means increase it by 1. So now x equals 2. We then go back up to the Boolean expression and then evaluate it. Is x less than or equal to 5? Yes, it is, because it equals 2. So let's go back inside to the loop body, where we print out x, which is 2. Then we increment x again. Then come back up to the Boolean expression. Is x still less than or equal to 5? Yes, it is, because x currently equals 3. So let's go back inside the body. We print out x, which is 3. Then we increment x. So now x equals 4. So come back up to the Boolean expression. Is x less than or equal to 5? Yes, it is, because x equals 4. So we go back inside to the body. We print out x. X is 4. Then we increment x. So now x equals 5. We come back up to the Boolean expression. Is x less than or equal to 5? Yes, it is, because x currently equals 5. So we come back inside. We print it out. Then we increment x. So now x equals 6. We come back up to the Boolean expression. Is x less than or equal to 5? No, it is not, because 6 is not less than or equal to 5. So then the while loop stops. Now, take a moment and pause the video to think about the importance of this instruction right here. Had we not included this statement inside the while loop, would or would not have that made a difference in this program? It would have, because had we not increased x, x would have remained equal to 1, and it would have never changed, which means x would always be less than or equal to 5, which means the Boolean expression would always be true. So the while loop would have repeated itself forever and ever, or until the computer eventually crashed. Hence why it's very important when you're writing loops, you need to have a statement in there that brings you closer and closer to a false evaluation. Okay? That way your while loop won't execute forever. Yes, there are some times where you may want to code an infinite while loop, but that's very rare. 99% of the time, you're going to want your while loop to eventually end, And to do that, you need to have code that pushes your loop closer and closer towards the false evaluation each time the body executes. Now, the following code demonstrates how to use a while loop to print values 1 through 5 backwards. So, first thing we're going to do is once again declare int variable x, but this time we're going to initialize it to 5. Then in the while loop, our Boolean expression, we're going to say repeat for as long as x is greater than or equal to 1. So, keeping that in mind, what I just said about for the previous example, how our code should include, how your loop body should include a statement that pushes you closer and closer towards the false evaluation. With that being said, would it make sense to increment x like we did in the previous code example? Would it make sense to increase x by 1 each time we loop if our goal is to move closer and closer towards a false evaluation? No, in this case, it wouldn't make sense because if I'm increasing x by 1 every time, I'm just further guaranteeing that x will always be greater than or equal to 1 every time the loop executes. I'm not moving closer towards the false evaluation, which is why in this case, increment is not what we want to do. What we want is to decrement x. We want to decrease x towards 1 so that eventually it's no longer greater than or equal to 1. Okay? I also use this example to highlight the point that depending on what your application is, depending on what your intention is, your starting point won't always be 1, okay? It could be 5, it could be 25, it could be 45, 50, 78. It all depends on your application, okay? Also, 10 may not be your stopping point. 1 may not be your stopping point. 4 could be your stopping point. 38 could be your stopping point. Again, it all depends on what your specific application is, what problem you're trying to solve. Okay? And then likely also, sometimes you may not want to increment or decrement, right? Sometimes going up by 1 or decreasing by 1 isn't what you want. Some applications may call for you to decrease by 3, or go up by 5, or go down by 7, or go up by 11. Again, it all depends on the application, but nevertheless, the concept is the same throughout. Now, for the remainder of this video, we're going to go over some important algorithms that use while loops. That's important to know because these algorithms can be generalized to solve all different kinds of problems. So yes, here in this video, we're focusing on one specific problem. The steps that we use can be generalized to solve a wide variety of problems. Now, the first algorithm being determining divisibility. Now, suppose I want to determine if some random number x is divisible by 3. Okay? One way to determine that is to start at 0, then count upwards by 3. When I do that, one of two things will happen. I'm either going to land right at x, meaning x is divisible by 3, or I will go over x, meaning it's not divisible. For example, I know that 9 is divisible by 3 because if I start at 0 and go up by 3, eventually I'm going to land right at 9. 10, on the other hand, is not divisible. It's not divisible because if I start at 0 and go up by 3 each time, I'm not going to land on 10. I'm going to go over 10. Right? So, suppose in my program I have a variable named x that stores some random positive number. I'm going to leave that part blank because, again, the number we choose doesn't matter. It's the steps that matter. It's the steps we take towards figuring out divisibility that matters. So feel free to imagine any number you want in that blank spot. So I have x, and I want to know, is it divisible by 3? So what I'm going to do is I'm going to declare a second int called counter. This is the variable I'm going to use to count upwards by 3. Then I'm going to write a while loop. I'm going to say for as long as counter is less than x, increase it by 3. So keep increasing counter by 3 until the counter is no longer less than x. That being said, once the while loop is finished, our job is not done because there's two reasons for why the while loop could have stopped. The while loop could have stopped because the counter became equal to x, or it could have stopped because it became greater than x. So we need to figure out why it stopped. To do that, we're going to use an if statement. We're going to say when the while loop is finished, if the counter is equal to x, that means x is divisible. So we'll print that out. We'll print divisible by 3. If it is not equal to x, then that means it must have been greater than x, which means it was not divisible by 3. Another important skill is knowing how to identify the individual digits in a number. This is very important with programming because unlike strings, where a string provides a char at method and other methods that allow you to it gives you a straightforward way of knowing what character is at a specific position. For example, if I have a string that stores some word like basketball and I want to know what's the third character or the fifth character or the eighth character, strings provide a straightforward way of figuring that out using the char at method or the substring method. Integers don't do that. If I have a 10-digit number and I want to know what the sixth digit is in that number, integers or doubles don't provide a straightforward way of revealing that. So we have to use tricks, algorithms to figure that out. So to figure that out, there are two facts you must be aware of when programming. The first fact, whenever you divide a number by 10 using remainder division, the remainder will always equal the rightmost digit of that number. So for example, 15, remember modulo is the number we use for computing the remainder. So 15 modulo 10 equals 5, okay? Because 5 is the remainder when you divide 15 by 10. 42 modulo 10 equals 2. 263 modulo 10 equals 3. 1,384 modulo 10 equals 4. 12,845 modulo 10 equals 5. Notice in each example here, the remainder was always equal to the rightmost digit of the number. The second fact that's important to know is that whenever you divide a number by 10 using integer division, the rightmost digit of that number gets removed. And recall, integer division simply means the fractional part gets thrown away. So for example, 11 divided by 10, if we're using precise division, 11 divided by 10 equals 1.1. But with integer division, we get rid of the fractional part. So it's simply 1. 263 divided by 10 using integer division is 26. 1,384 divided by 10 using int division is 138, so on and so forth. Notice that in each example, when we divided by 10 using integer division, the rightmost digit got removed. With these two facts combined, we can then now identify individual digits in a number using an algorithm. The following algorithm will use a while loop to identify each digit in X, where X is an int value. So here's our code. We're going to declare a variable named X, and again, give it any random positive number you want. The number you choose doesn't matter because the steps are still the same. It's the steps that we use in determining the digits that matters here. So we declare X, then we enter our while loop, and this while loop is going to repeat for as long as X is greater than 0. Because once X is equal or less than, whenever X becomes less than or equal to 0, that means we've processed every single digit. So when we enter the while loop, the first thing we do is print out the rightmost digit. That's why we say print out X modulo 10. All we're doing here is printing out the rightmost digit. Then we get rid of that digit. We get rid of that digit by dividing by 10 using integer division. Okay. We repeat the process. Print out the rightmost digit, which will now be what was originally the second rightmost digit. We print that out. Then we remove that digit. Okay. We keep repeating this process until all the digits become removed, thus making X equal to 0. Determining frequency. The following algorithm uses a while loop to identify the number of 3's in X. So for this algorithm, this algorithm is going to be very similar to the last one in that it also requires us looking at every single digit. But here, our goal isn't to print out every digit. Our goal is to see how many of these digits are equal to 3. So once again, we still want to look at each digit, but instead of printing it out, we're going to determine if it equals 3, and then we're going to keep count of the number of digits that equals 3. So that means we're going to need to we're going to need a second int variable we're going to set equal to freq, which is short for frequency, and we're going to use that variable to keep count of how many 3's are in X. So we enter our while loop using the same expression as before, and now we have an if statement. Instead of printing out the rightmost digit, we use the if statement to see, is the rightmost digit equal to 3? If it is, increase frequency by 1. After doing that evaluation, remove the digit. Then repeat this process on the next digit. Determine is that digit equal to 3? If so, increase frequency by 1, then remove it. Repeat until the while loop ends. until all digits have been removed and x is no longer greater than 0. After that's done, print out the frequency. Determining the maximum value. The following algorithm uses a while loop to determine the largest digit in x, an int value. So now we want to know the largest digit. So once again, just as before, we're using while loop to look at every digit, but instead of printing it out, we want to know, is this digit the largest digit in x, which is going to require an if statement. So once again, we declare a variable x that equals some random positive number. Then we're going to have a second variable called the max that we're going to use to store the maximum digit in x. Right now, we're going to initialize it to 0 because I feel that's a good starting point, because I know that any digit I encounter is guaranteed to be at least 0. So that's a good starting point. So inside our while loop, we look at the rightmost digit and then we compare it to the current value stored in max. If it's greater than the current value stored in max, then that digit becomes the new max. Then remove that digit from x. This prepares us to evaluate the next digit. So we say, all right, now is this next digit, is it greater than the current value stored in max? If so, then that digit becomes the new max. And then we remove that digit. We repeat this process until all digits have been removed and x is no longer greater than 0, which at that time we will then print out the max digit. Adding up all values. The following algorithm uses a while loop to add up all the digits in x. So once again, we're using while loop to look at every digit in a number, but this time we're adding them up. Okay, so once again, we declare x to equal some random positive number. Then I declare a variable. I'm going to name it sum because I'm going to use it to store the sum of all the digits in x. Then inside a while loop, we're going to process each digit. What I'm going to do is I'm going to add the rightmost digit to the sum variable. Then I'm going to divide x by 10 to remove that digit. Okay. Then we repeat this process every time, adding the digit to the sum and removing it, repeating it until all digits have been removed from x. Okay. When that's done, we print out the sum. Computing the average. Now, the following algorithm uses a while loop to compute the average of all the digits in x. Now, the algorithm for computing the average is the same algorithm. It's the same as the algorithm we use for adding up all the values, but with 2 extra steps. First off, we need a variable that we're going to use to keep track of how many digits are in x. Then in our while loop, every time we process a digit, every time we add that digit to the sum, we increase count by 1. This is how we determine how many digits are in the number. Then when the while loop is finished, we take our sum and divide it by the count. That's how you compute the average. So again, we're doing the same thing we did before, where we're adding up all the digits together and putting it in a variable named sum. But now we have just a few additional instructions so that we can keep count of how many digits are in there, so we can compute the average of all the digits, then print it out.